on this document that we're beginning with today, currently all it does is it just writes out that little bit of text. There's the window onload init, the function going on with that. There is a paragraph with its ID on it. And that's all that does. I have a shell document when I use Sublime that comes up and it populates it with a blank init function that if I wanted to put something in it, and I thought about using it and left it and decided not to do it anymore. The real function of today's topic is to start talking about things as objects. Everything in JavaScript technically is an object. That's how JavaScript works. It doesn't work in the same way as other object-oriented programming languages do. It is a prototype-based language, and there will be more coming on prototypes next week. But today I wanted to get into the basic foundation aspects of working with these objects. So I've created a Fido object up here. This is Fido. He's a nice little puppy. He has a name of Fido. He weighs 40 pounds. He's a mixed breed, and he loves walks and chew toys. Now, if you look at this object that's been created, what this really is, it's nicely aligned, and this is a common convention of working with it on multiple lines, so it's a little bit easy to see. But if you notice with the curly braces, it effectively is creating something much like an array. So if I delete the extra spaces out of here, we'll see that it's just a comma list. Oh, got rid of one too many. So it just ends. So I have a list of items. So property, value, comma, property, value, comma, property, value, comma, property, value. And the value can be numbers, it can be a string, or it can be an array. And then a closing curly bracket and a semicolon. This notation is referred to as an object literal. So we will have an object constructor that we will use a little bit later. But right now this is an object literal. So I'm taking this variable Fido and designating it as an object with these properties. So Fido has a name, it has a weight, it has a breed, and it has loves. Noticing how property value, property value, property value separated with commas. The last one does not have a comma after it. And with the common way of designating these, where we, oh, I'm a little typing issue here. The common way of designating these using commas, you have to remember the last item, you don't put a comma after it. So when you saw it on one line, it makes sense not to have a comma after that last item, because you don't put the comma after the last item when you're doing a comma delineated list. But it's very common when you describe an object literal where you have property value comma, and because you copy paste and do other things, you get in the habit, you put a comma after it and then the thing breaks. And because JavaScript likes to fail miserably silently, where the error messages are less than helpful at best, you just have to be aware of it. And it also, because of its structure, it always then ends with a semicolon. So when you define an object literal, it ends with a semicolon. Think of this as we've talked about defining functions in the past. When we define the function with var, our function name equals function, parenthesis, close parenthesis, curly brace, and then we ending curly brace and a semicolon, because it's a variable object. If we used a function declaration where we said function, the name of it, we don't have to have the semicolon at the end. But JavaScript is pretty good about figuring out where semicolons do and don't go, even if you forget them. So that is just something that you can probably be slightly wrong or lazy with your semicolons, and it's not going to haunt you. But this semicolon here is considered proper. The lack of comma here is considered proper, and that part is mandatory or it will fail. So this is now my Fido. This really should just move over one more. Look a little cleaner. This is my Fido object literal. So now that I have Fido, we can access properties of Fido. We can say Fido.weight. So we're using the dot notation. We can use the bracket notation because effectively an object literal is an array. So we can use the bracket notation to access things. But most times we use the dot notation. So we say our object dot and then the property we're trying to access. So the simple conditional says if Fido weighs more than 25 pounds, alert woof, otherwise alert yep. So if I save this and go back to Chrome and run it, it alerts out woof because Fido is greater than, his weight is greater than 24 pounds. So if I'm making 100 objects, using literals is a really bad form because I have to construct 100 items just like this. So if I had var Daisy, name Daisy, weight, Daisy's probably a very dainty dog. I'd say 15 pounds, breed, one of those small little puntable, throwable kinds of small dog breeds. And Daisy loves to dress up in ridiculous outfits and bark at strangers coming at the door and try and bite their ankles. So then we have other objects, other dogs we'd define, and pretty soon we realize after our whole animal menagerie is defined that, wow, using literals, while it works and it's really easy to read and understand it, it's a pain. Because if I have to define every object, it's not a very efficient programming practice. So as we move from an object literal to an object constructor, then we'll realize we can make what would be a master object that we're able to use to construct the effectively child objects or multiple instances of that master object. So that's what we will get to shortly. So we can query properties. We can say Fido weight is bigger than 25. We can also put Fido on a diet. And we can say Fido's weight is now 23 pounds. Now if I leave that line where it is and run this in the browser, once again it says woof, because Fido's weight is 23 pounds. If I move that line up here, we will find that we get a different result. Yep, because now Fido's weight has been changed. If you're working in Chrome, you can even type some of these things in. Oh, I forgot. Here I have to actually, wrong key. Fido.weight. So you can type in the console if you want to know about variables and properties that are there. You can write queries directly. So you can test little bits of logic without having to write them in your JavaScript. Once the JavaScript's been loaded, that object is in memory. So now I can query that directly in the console. So when we type in console log Fido, it says, hey, that's an object. It has a name, Fido, weight, 23, breed mixed, and loves an array of 2 elements. Now notice the weight is 23 here, though Fido, the object started with the weight of 40. But we modified it by using this assignment expression where we assigned the weight of Fido to this new number.
Why don't you have to?
Now, Fido has some loves. Fido loves walks and chew toys. So we're going to create a variable called likes and set it equal to Fido's loves. going to create a variable called like string and set that equal to Fido likes. Using a simple for loop that will cycle through however long likes is, the length of likes, which in this case is 2. And then it takes like string and adds to it each time it cycles through a space, and then it accesses an element in likes starting at 0. So like 0, which is Fido loves at position 0, would be walks, and then it cycles through again and adds another space, and then it would add in chew toys. So if we save this, and Fido doesn't need to go on a weight reduction, so I will comment that back out. And refresh this, we'll say Fido likes walks, chew toys. It's not great grammar right now, but it shows that we can now cycle through and build a composite string. So we can create a string by using plus equals, the same way we use plus equals with numbers. So we can say like score plus equals 1. Each time then it makes score bigger than its previous value. Here we can now add words to it. So to clean up the grammar on this and use and commas, and we'll do it all properly with it. Then what we can say is if I is let's see, we're looking at I is equal to or less than likes dot length minus 1. So if it's less than lengths minus 1, then it will be like string plus equal likes I plus comma space. So that would be for all of the first elements, because this stops going when I is set equal to the length, so it won't run. But one less than that is the final element. So everything lower than that, we want it to put a comma after it. Then we can say else, and I'll just put that up, over, and add in likes. And then as long as we're trying to clean up the grammar on it, we'll add in a period at the end as well. So it puts a period at the end. And then when we have it like this, we still need to do one more thing, but we'll try and run it like this to see how it's going, and add in walks, chew toys, and eating. And eating pancakes. Okay. So if we save this, cruise over, refresh. Fido likes walks, chew toys. Oh, and then the final one we have to add an and. Notice also Fido likes walks, like walks became one word because we aren't adding the space in, because previously it was like string plus equals space plus equal likes I. So if we add a space up here, that takes care of that. And then we need to add in and. So it gives us a proper grammar on the list. And the good part is I am a firm believer that when you do a comma delineated list, you always have a comma in front of the and. Some grammar police do not believe you need that comma, but I believe when you have a list, you should always have the comma before the and in front of the final element. So it works, but that's not quite as nice a code because we had to add in a few more lines. The other way was to get the point across, but because you guys demand greatness, I feel okay that we got to build this in and make it a little bit cleaner and better language. Now, something else we can do with objects is we can assign additional properties and give them values outside of our object literal. If you notice, Fido has a name, a way to breed, and loves. Fido does not have an age yet. But if I say Fido.age equals something, Fido now has an age. And by choice, I chose to use a number, but age could be anything. It could be a string. I could say 5 years or 3 years old or something like that. But if we run this now, we'll see 3. Now if I change this from a number, I can certainly change that to 3 years old. And now alert, I could say alert Fido is, and now when I run this, Fido is 3 years old. I've defined Fido's age here. I'm going to go get rid of that Fido there. We're going to have a different Fido here. So I could say var Fido equals curly brackets indicating Fido is an object, and then just Fido.name equals that. So we could just as easily define the Fido object and then define all of Fido's properties outside of that object definition. Perfectly legal, perfectly useful, perfectly functional. So this is essentially this. Object, property value. Object, property value, property value, property value. This is not very efficient coding, but completely and utterly legal.
Will you repost this file?
And fixing this to make it correct. The colons, when we define it this way, we use colons when we're defining it in object literal notation. When we're assigning it afterward, we use the equal sign. So object.property equals value. Object.property equals value. Object property equals value. Oh, and commas become, I thought I'd changed all of those, and apparently I was being super lazy. Semicolons. Because the semicolon is the period at the end of a sentence. Object.property value, object.property value. All right, but now this particular object we're not going to use anymore because my other one is still available, and I know that one does work with my code. So now I've created a function here. My function is bark. Now I'm using a function expression, not a function declaration. So I say var bark equals function. And now I'm going to pass to this function something. Now I use the word dog, and there I could use anything I want, but because we're conceiving of Fido as being a dog, it just made sense to pass that in. So var bark equals function, and then I'm passing in an object to this function, and it is a dog object, and I know that my dog objects have a weight to them. So if I want to call this function, I can say bark, and then I send Fido to the bark function. So Fido goes into the bark function, and then that says, hey, if that object's weight is greater than 25, say woof, otherwise say yip. So we can save this on the page, and it says woof because he has not had his weight loss surgery yet, so he's still up at the 40 pounds. So I can call a function. It's the same as other functions that we've written here and in other languages where we have function in parentheses. I pass in the parameter I'm trying to work with. Nice part about JavaScript is I don't have to type that object. I don't have to say, is it a float, is it an int, is it a ball, is it a drop, is it a... It doesn't care. I just say, yeah, there's a parameter, and then it will do its best to understand that object and hope that object has that value. Now, from a programming standpoint, that this works. If I were more serious about it, I would probably want to put some error checking in. So I would say, hey, try and do this, and if it doesn't work, catch the error and then give me this message back that there was an error. So we use this try-catch methodology that we will look at as our programs get more and more complex, because you never want to have your thing fail, and because JavaScript is not going to care whether I pass a number, a dog object, a word, a string, an array, or any. If I just say bark and send something to it, it's going to do its best to try and make that work. It's a dynamically typed language. It's not very picky in that regard. And this is one of the characteristics that a lot of developers are loving about JavaScript, is that it's not so picky about you have to define every variable with its type. You have to define every parameter with its type. It allows you just to do. And in that sense, it can be a little bit faster.
Why is the dog
Now it's time to turn weight loss into a function. So we have a different function here. So instead of just querying a property of Fido, we're going to change a property of Fido. So right now, my function says lose weight equals function. We're going to pass to it our dog object, and then we'll take the weight and subtract 13 from whatever the current weight is. So minus equals 13. So Fido gets to lose weight. Now, it's set up with a couple of different alerts here. All right. Let's go find out what it says. So if we run 40, okay, Fido now weighs 27. So we've proven that we can query the property of the object, pass the object to this function which performs an operation on that object, weight loss surgery, and then we can query the object again and say, oh, by the way, what's your new weight? And we also queried it and asked Fido to tell us his name. So we can have a function. Now it's also possible as part of this to do it a little bit differently. And this is the one that I think is a whole lot more fun with it. Where at this point, instead of just passing in the object, we can also specify how much weight we want to lose. So we can take our lose weight function and add 2 parameters to it instead of just 1. So on this function, I pass in my dog, I pass in the amount I want Fido to lose, and then we can say, why don't you lose that amount of weight? So instead of a fixed weight loss program, this is a variable weight loss program. He paid extra money for it. So we can now do it. So if we refresh, it says 40, but now this time it says 22 because we passed in a value of 18. If we only wanted to lose a couple pounds, like say 2 pounds, we could do that. And now when I run it, 40, he's down to 38. So it's a more flexible way of working with the function is by having it with multiple parameters instead of just 1. So I can pass in my object. I could pass in multiple objects. I can pass in multiple objects plus additional values. So we have object and then the value that we are modifying that object by. Okay. So we had our loose weights, done with that. Now we're going to look at an example of, we can also have an additional object literal. This time I have Bruno. He's a bulldog, 72 pounds. He's big. It should also say eating rabbits. He likes sleeping, chasing rabbits, and eating rabbits, which is why he weighs 72 pounds. Now, he can have a built-in function of growl. So not only can objects have properties, property value, and those values can be numbers, strings, arrays, whatever we want, but the property can be a function. In this case, the function is growl, so he has his own function assigned to him. So that means I can have Bruno and I can tell him to growl. So he has his own special function built in. And when an object has a function attached to it or associated with it, that is referred to as a method. It's a method of the object. So that object is capable of growl because that is his method. Now Fido doesn't have any methods, so Fido is kind of mute. He can't growl. He doesn't know how to growl because he doesn't have that method. So we save this and run it. We'll see that grrr because Bruno growled at you. That's what he did. So these are using object literals. But if we now have 4, 5, 8, 10, 12 objects and define each one this way, that's highly redundant coding, and it's also very annoying coding to do. So what we are going to look at next is using a constructor, an object constructor instead of an object literal, and then that allows us to create a generic object that we can then create instances of that object with the properties that we're looking for. The next part on objects. So we have our existing object. We have our bulldog Bruno, and he can growl. He has a method associated with him. But if we start creating more and more objects, this is a hugely cumbersome pain in the butt way to work. So a better way is to use our constructor, our object constructor instead of object literal method. The object constructor, var dog equals function, pass in the parameters we want when we make a critter, and then we introduce a new concept here. This. So what it does is, if you compare it to on Bruno, Bruno is a unique individual object. His name is Bruno. When we use this constructor function, we're passing in a name value, and we're setting our name property of this object, but of this instance of the object when we're going to use it equal to name. So it's this. So in a constructor function, all of your properties are defined using the word this.
Does it have to be the word this?
And it can't be that. It must be this. It must be the word this. It's a reserved word. So don't use the word this for anything else in your programming. It is a reserved word in the language, and it's used inside constructors because it refers to the unique version of that particular thing. So if I create Spike and he's a dog, pass in his name, his breed, his weight. So if I create a different dog, and then if I query that object's properties, they will show up as unique items because we used the magic word this. So when you are creating an object with a constructor, we define things with this. And if we had even something else like this dot color equals, and if we just are assigning all of our dogs a default color of brown, that means every dog has a color of brown. I'm not passing in the color, it's just every dog created is brown unless I change that property at a future date. But it gives me a property. So if I run this right now, Spike is going to bark. Bark as a function is defined that if the object's weight is greater than 25, they say wolf, otherwise they say yep, okay. So we know that. If you wanted another method, we could pass that in as well. So we could have addition, or if you wanted to have other methods, we could have those. Because we could even do this dot eat equals function. This dot weight plus equals 2. So when this object eats, it's going to gain weight. So first we will prove that we have Bruno and Spike. Bruno says grr, Spike says yep. Okay. Actually we should, I'm going to change this and say it's just no fun if it only says Bruno, just grr. So Bruno says grr, Spike says wolf, and now we can say Spike.eat alert. And then we'll alert out Spike's weight. Bruno says grr. Spike says yep. 24. When Spike was created, he weighed 22. Now he weighs 24. Spike.eat. Spike.eat. And we can see now Spike weighs 28 when I log out his weight. So by telling him to eat and eat, he went from 22, then to 24, 26, 28. So we've now, Spike has an eat method, and we can see when he eats, he gains weight. So he probably needs to scale back a little bit on the food then, or go to a lower fat food if he's going to gain weight that quickly. The syntax that we're using to constructor objects, var the variable name equals, and now we have this other special word called new. And we're making a new, and then we say what, and the what corresponds to the constructor function that we wrote previously, and then we pass in the parameters that it is going to be looking for. And that is how we can create a generic object that we can then use for making our objects. Because if we look at making Bruno or making Fido, it's a lot of typing. Once you have your constructor function done, it's much cleaner to make a new object. Var the object equals new, and that key word right there, new, is super 100%, 110% critical. By saying new, it says make a new copy of this object. That's what the new word does. Or not even copy, make a new instance of this object that is individual and unique. It's not a copy of the object. I mean, you could say that, but it's a unique instance.
What happens if we don't use new?
We don't use new.